Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, I'm going to show you a very simple shell script that you can use to identify some out-of-place inodes. In a previous video, we talked about how if someone puts something in one of your bin directories or sbin, you might have a sophisticated attacker that fixes the timestamps, but they might have an issue that you can still use to discover their activities because the inodes used for those new files will probably not be sequential with all the other inodes when the system was installed and everything was laid down. So this is just a simple script that you can use to make it a little bit easier than just running the ls command that I showed you earlier. So here's our script. We start out with shebang bin bash. I define a little usage function, and it says run this script and give me a path. I will give you a printout of files in that directory with their inodes, and I will also tell you if there are any gaps in the inodes. So here I check and see if you gave me less than one argument. Then I will yell at you and I will give you the usage statement. And here's the main script. So the first thing I do right here is I output to a temp file. And why do I do it this way? This is a little bit more efficient way to go. So I run my ollie. We talked about that. All files, long entries, inode information, capital R for recursive, in case there are anything in subdirectories. $1 is the parameter you passed in, and I sort it numerically, and I put it to this temporary file. I then declare a couple of things. I have found first inode. I set that equal to false, and I declare an integer value. That's what this means here. Declare -i called start inode. These are used for getting rid of some of the lines at the start of this file. So when you sort it numerically, you will probably have a line or two at the top that are not actually files. They will say something like ls/bin:, for example. So those you don't want. So here I read in the file line by line, and if you go down a bit, you will see this is a construct that you can use. I say while read line do, and down here at the done, I have less than and then my file name. So what this does is it processes this file that is given by temp ls, and I go through it line by line, and each line gives me one iteration through this loop. So here I'm dealing with those start lines, and I say if found first inode equals false. So I haven't found a legit line yet, so I echo the line out. I pipe that to word count -w, which says, please just give me number of words. Otherwise, it'll give me characters, words, and lines. I don't want that. I just want the one thing. This is in backticks, which causes this to be executed. And then that result is stored in double quotes. So it's a string. And I say if that is greater than 6. And why greater than 6? If you look at the output from this ls command, you will have at least 7 columns of output if it represents a file. So that tells me I've gotten to the start, semicolon, then, and what do? All right, I say that my starting inode number is, and let's break this one down. It's a little bit complicated. I echo the line and I pipe it to awk, in my awk program, if you will, says please print the first word, which should be the inode number. This is inside of $ followed by parentheses, and that takes all of this and turns it into a signal argument, which is passed to expression. That means please evaluate this expression and return the result. So this is in backticks, which causes that result to be stored in my integer. Again, I declared this as an integer up here, start inode. And you'll see why I needed to declare that as an integer here in a little bit. And then I set found first inode to true, and then I continue. So here, I'm going to echo out the line, and again, I pipe it to awk, and I print the first word, and that's Q. All right, so that's my current inode. And I say, if my starting inode is less than Q, then I'm going to print out a warning. And what I've done here is I'm using escape commands to print it in different colors. And we'll see the output of this in a bit. So if it's drastically different, in other words, I skipped more than a couple of inodes, I'm going to print it out in red. I'm going to give you a message saying out of sequence, inode detected. I expected this and I got something else. If it's just a couple, I print it out in yellow instead. If I have the situation, I reset the starting inode using the same construct I used earlier with expr and echoing the line to awk. Here's the end of my if statement. I then echo the line. So regardless of whether or not there's a missing inode, I always echo the line. Then I increment the start inode, and this is why I had to declare this as an integer. So this is a construct in bash where if you say $ and then double parentheses, you can put it into what they call math mode. So I can say this thing is equal to itself plus 1, please. And here's the end of my loop. Great, so let's go ahead and we'll run this script real quick. And I'm going to start by running it on my local bin directory just to show you what it looks like. So I'll run out of sequence inodes on /bin, and I will pipe it to more. And you see the first one, the starting inode was 2, and inode 2 actually points to the root directory, so this makes sense. And then I have the rest of my inodes. So notice this is printed in red, telling me it's a big jump. Here, I was expecting 81 and I got 82, so it's printed in yellow. And then here you can see some bigger gaps. I can repeat this on my local bin. I get some similar results. I can go ahead and mount my image, which is at Media, Fill, Toshiba, Disk Images, 2015 9. And that's been nicely mounted for me. I can rerun my script, and I'll run it on Media, Part 0, Bin. And again, I'll just pipe it to more. And as expected, the first sequence has a big jump. And then there's another big jump when I go to bash, and I see a big jump a little bit further down, but nothing too extreme. And there's a huge jump here for all of my suspicious programs related to my rootkit. So you can see that did a pretty good job of saying, hey, look at this. This is suspicious. I'll go ahead and rerun this real quick on SBin, and I will get some similar results. Great. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.